Hey, Jen Lexmond here. I'm tagging in for 8001C, and we're starting with a bit of a doozy, factoring one, where I'm going to cover three topics: common factoring, difference of squares, and how to factor simple trinomials. Now, you are not obligated to sit through this video. If you look at the slides, I have references to where to find them. So you're more than welcome to try the slides, and then if you need to come to the video, come check it out. If you really dig math videos, want to watch 45 minutes of it, by all means. The first type of factoring I want to talk about is common factoring. So let's go ahead with these slides. So to take it back, we're going to speak about what factoring even is. So when we were talking before, we were talking about distribution expansion, and that was where you would take your thing outside the brackets and you would make sure that you multiplied it by everything inside the brackets using FOIL for binomials or the array, and just kind of distributing for monomial binomials. So we would have 2 times x is 2x, and then 2 times 3 is plus 6. And down here we do first x squared, and then outside minus 4x plus 2x, and then last minus 8, and we would look at this and be able to combine a couple of terms into x squared minus 2x minus 8. Okay, so that was expansion and distribution. So when we do factoring, we are going to start in this location or this location, and we're going to take things out and put them back in front. So we're adding brackets back into the equation. It is the opposite action. So talking about common factoring, this must always be your first step. Always, always, always. So no matter what you end up doing factoring-wise, if you do quadratic factoring or difference of squares, do common factoring first. It will make your life a lot easier. So you're going to look at a polynomial, a list of things, and you're going to see if there's anything that is common to all terms. So let's take our one we had before. I can't remember what it ended up at, but let's say it ended up at 2x plus 6. And I look at this first term and I'm like, there's a 2 and an x, and I look at my second term and there's a 6. Now I can't do anything about x's because x is not common to all terms. However, both terms are even in the numbers and are divisible by 2. So that means that the number 2 is common. So I have a common factor for this binomial of the number 2. And what we're going to do with those common factors, we're going to do some division to divide them out of all the terms, and then we put them in front of our sentence, math sentence, and we add some brackets to protect what's left from them. So let's try a few. Here's my first one. So in 12x, my numbers are 6 and 12. And I know that 6 goes into 12. 12 doesn't go into 6 evenly. So you always want to make sure these are making integers, even numbers, like not even, but like whole numbers. You don't want to be doing, I could divide that in and have 1.5 or 3/4. You want to be getting nice whole numbers from that. So I know that I have a common factor in the numbers of 6. And when I look at x and x squared, x can fit into x squared, so I can take that out, but I can't take out x squared because x squared doesn't fit the other way. Okay, so you're always limited by your lowest exponent when you're talking about variables. So I can take 6x out. So my action is, and this is not a step you have to show, I'm basically dividing 12x by 6x and 6x squared by 6x. And when I do that, the x's will cancel. Over here, 6's will cancel, x, I'll have 1x left. So I'll make a statement that is 2 plus x. And what's left over, you put the thing you your divisor out in front. And how can you check if you did it right? Go the other way. If I factor this correctly, when I distribute, I should get back up to 12x plus 6x squared. 6x times 2, 12x. 6x times x plus 6x squared. So that is the correct answer. Looking at number 2, My numbers are 6, 20, and 4. So I'm looking at the lowest number. 4 is not going to go into 6. It does go into 20, so that's no good. So I drop it down. 2 will go into 4, 6, and 20. So that's my greatest common factor of the numbers. And I look at my x's. I have x squared, x to the power of 3. So I can only take out the x to the lowest exponent, so I have to just take out a plain old x. I'm going to put the rest of the stuff, the leftovers, in brackets, and I take 6x cubed and I divide it by 2x. 6 divided by 2 is 3. X cubed divided by x squared. And moving to the second term, negative 20 divided by 2 is 10, negative 10, pardon me, and x divided by x, they all disappear. Because they're 1, not because they're 0. And we're going to look at 4 divided by 2 is 2, positive, x squared divided by x, I'm just going to have x left over. So that's my factored form. So when you do this, kind of take a look at what's left in the brackets and make sure there isn't another factor you've left behind. Like if everything still had an x in, I should have taken out more x's. Or if everything was still even, I should have taken out another 2. So double check your work at the end to make sure that you have factored it completely. Number 3, I've got 3, negative 6, and 12. So 3 can go into all of those. And then I have A, and A. A is common to all terms, so I can take out an A. And I have B, B squared, and B cubed, so I can only take out B to the power of 1. When I look at my first one, 3AB squared divided by 3AB, the 3 and the A will cancel out, and I'll be left with just a single B. Looking at the second one, negative 6 divided by 3 is negative 2. A divided by A is 1. B divided by B is 1. They're gone. 12 divided by 3 is 4. A divided by A is 1. No more A's left. B cubed divided by B leaves you with B squared. And once again, if you're not sure, do that distribution like we did in number 1 and see if you get back to the original question. And let's go over and look at number 4 now. So in the next slide or the slide after, I have a note where I say always take out the negative of the leading term. So I'm just going to take out the negative because it'll make everything look nicer inside. I can't take out negative 4 because 18 is not divisible by 4. So I'm going to have to drop it down. They're all even, and take out negative 2. So looking through, I see s cubed, s, but my third term has no s factor in it. So I can't touch the s's. Now let's look to the t's. I have t to the power of 1, t to the power of 1, and t to the power of 2. So I'm just going to take out that t to the power of 1. All right, negative 4 divided by negative 2 is positive 2, s3. Negative 20 divided by negative 2 is positive 10, s. And negative 18 divided by negative 2 is positive 9, single t. And once again, just to really drive it home, check your answer if you need to by putting the negative 2t back in and making sure that you get back to the original question. So if I do that, I get negative 4 s cubed t, negative 20 s t, and negative 18 t squared. Okay, those are the same thing, so I've done my math correctly. Unusual common factors. So ours so far have always been variables and numbers. And I just want to really draw attention to the fact that it doesn't matter what it is, as long as it's in all of the terms, it's a common factor. So my first example is kind of silly. I'll look at the numbers, 15, 3, and 10. Nothing goes into all three of those numbers, so I'm not going to be able to take out any numbers. So, but now I want to look at the shapes. I have squares, and I have hearts, and I have a square to the power of 1, so I can take out a square. I'm not going to test you on this kind of stuff. It's just trying to drive something home. It doesn't have to be an X or a Y. It can be something different. And I have hearts, and I have my lowest power for the hearts at the heart to the power of 2. So I can absolutely take this out. square, heart squared, that's terrible, is common to everything. All right, so let's go 15. We have 1 square left behind on this one, and a heart. Okay, -3, I'm not touching anything. We have 3 squares left behind on this one. And hearts are going to divide out. Last one. A square with a heart squared divided by a square with a heart squared is 1, and they're left behind. So you're allowed to do that. So bearing that in mind, and the reason I show you that is because people have a really hard time with this next one, even though we've discussed terms and factors before. This binomial is the same as this binomial. So it is a factor, and it can be divided out like anything else would. Like if I had shown you that question, an equivalent question for number 2, where it was 8y cubed and just plain old x7 instead of 3x plus 4 to the power of 7 plus 24y x5. People have no trouble dealing with the x's. People have trouble wrapping their mind around the 3x plus 4. Same. Just go ahead and do it. All right, so let's look at this. 8 goes into 24, so I can take out all of the 8. Y cubed and y to the power 1, so I can only take out this. And then I'm going to remove as many of the binomials as I can. I've got to the power of 7 and to the power of 5, so I'm going to take out to the power of 5. And then I have another set of brackets. And I'm going to see that the 8 divided by 8 is 1. Y cubed divided by y leaves y squared. And the power on the binomial is 7, and I'm dividing that by the same binomial to the power of 5. 7 minus 5, thinking exponent laws, leaves this behind. 24 divided by 8 is 3. Y divided by y is 1, so we don't have to write anything down. And 3x plus 4 to the power of 5 divided by 3x plus 4 to the power of 5 is 1. So we're done here. And then the final thing is to look at what happens with fractions. So I see that I have 1/4, 7/4, and 3/4. So look to the biggest quarter that you can pull out. So I'm going to pull out 1/4. I'll do something on the side in a sec. And I have no x's in my third term, so I can't pull out any x's. And y's, I have the power of 1, 2, and 3, so I'm just going to take out that. So this is what I'm going to factor it. And if you're having trouble thinking about what gets left behind, well, a quarter divided by quarter is easy, right? You know that's gone. So you're just going to be leaving x squared in the first one. For the second one, if you're having trouble thinking about what 7/4 divided by 1/4 is, do the fraction math. And once you get it, you'll get it. So noticing that I'm using that x as multiplication like we're in grade school. And you're going to get 28 over 4, or you're going to cancel the 4's. And you'll notice that what's left is the numerator. So every time you do these ones where the denominators are all the same, you're going to be left with just the numerator. Plus 7, no x's coming out, 1y coming out. Last one, if I did the math drawn out, I would see that 3/4 divided by 1/4 is simply 3, and I took out 1y. So just let these things happen. It's okay to have weird common factors. Definitely take a minute and try this one on your own to make sure you've got it, because these are ones that are totally fair game on the test. Once again, I'm kind of harping on if you see, especially when these ones just have x's and it's going to turn into something that you'll probably be doing quadratic factoring on, take out the negative in front. It makes your life easier. So for this one, number 1, I see -4, which will go into 20, and which will go into 24. So I'm going to take that out. And then my highest power of x, or my lowest rather power of x, is x to the 1, so I can take that out. When I divide -4 by -4, I'm left with just 1, so I don't see anything. And x cubed by x squared. Positive 20 by -4, minus 5, x squared by x. Positive 24 by -4, negative 6, x by x, 1. And it turns out you will be able to factor that one further. Looking at number 2. Lowest number is 15, but that's not going into anything, but they are all divisible by 5. So that's what I'm going to take out. 5. And then my lowest power of x is x3. And my lowest power of y is y7. So I can take all of that out. It's like crazy planes flying over my house right now. All right, 25 divided by 5 is 5. x4 divided by x3 leaves a single x, and all of the y's will go. All right, negative 40 divided by 5 leaves negative 8. x3 over x3 gets rid of all your x's, and y8 divided by y7 leaves a single y. And then 15 divided by 5 is 3. x5 over x3 leaves x squared. y7 over y7 is 1, so they're all gone. So just looking at what's left behind in the brackets, making sure that I can't divide out any numbers or variables further. Nope, we're good. And if I wanted to check my work, you know what to do. Put that thing back in and hope that you end up at the original polynomial. All right, in our last example, we have numbers, we have x's, and we have 2x minus 7's. So those are our three things that we can consider factoring out. 3, 6, 15, all divisible by 3. x4, x cubed, lowest power is x. And we have a binomial, so I'll just write it down because it's in all of them, so I know I'm taking it out. To the power of 5, to the power of 4, and to the power of 6, so I can take out 4. I'm going to use square brackets, doesn't matter, just trying to make it a little clearer. So our first term, 3 divided by 3 is 1, x4 divided by x, x3, and 2x minus 7 to the power of 5, and divided by the power of 4, plain old. All right, second term, negative 6x divided by, I'm kind of cheating ahead here, but divided by 3x should just leave you with negative 2, and same power on the binomials, so those will kind of cancel each other out. Third term, negative 15 divided by 3 is negative 5, and then x cubed divided by x, x squared, and we'll have 2x minus 7 to the power of 6 divided by the power of 4. 6 minus 4 leaves you 2. And done. Let's talk about difference of squares, what that is, how to recognize it, and how to get what I consider to be free marks. So a difference of squares, it's a name for a special algebraic product, and you can see that definition, and it's on your formula sheet as well, right up here. Now, you'll notice it's saying a squared minus b squared can be factored into a plus b, a minus b. So what does that mean? When you look in a factoring question, you're thinking about doing difference of squares, you should see two terms, 1 and 2. Both of them should be squares, perfect squares for our course. Like if you were doing this in kind of more advanced applications, they wouldn't have to be, you could use root signs, but ours are going to be perfect squares. However, this might be hidden because you might be needing to do some common factoring first to reveal those perfect squares. And the other key thing is that there's a negative sign in between them. So if I see something like this, not a difference of squares. The A is a square, the B is a square, but the sign in between is a plus sign or a positive sign. So this is not factorable. This will not work. So just bear that in mind. So let's look at how the pattern goes. And we're going to start by actually expanding x plus 5, x minus 5. Because when I look up here at the top, that should be the factored form of a difference of squares. So using FOIL, first x squared outside minus 5x inside plus 5x last. minus 25. Noticing that when you combined the outside and the inside terms, minus 5 plus 5 is 0. So that completely disappeared, and you're left with x squared minus 25. All right, which is a difference of squares. Once again, on the second one here, expanding x squared minus 4x plus 4x minus 16. And it's going to leave you x squared minus 16 once you cancel out the minus 4 plus 4x. All right, knowing that, looking at number 3, what do you think that's going to factor to? Well, what's the root of the first, the a kind of term, I'm calling it here? The root of x squared is x. What's the root of 9? 3. So you're probably going to have something that's x plus 3, x minus 3 when you factor it. And that's going to be the same thing every time. So if I look at the first term, the math I'm doing is I'm like, oh, what's the root of 9x squared? The root of 9 is 3. Root of x squared is x. What's the root of 1? Well, 1 is great. So there it is. You're going to build that factored difference of squares. 3x plus 1, 3x minus 1. Looking at number 2, root of 81 y squared. Root of 81 is 9. Root of y squared is y. And then the root of 4 is 2. So there's your factored form. 9y plus 2, 9y minus 2. And if you're not sure, once again, just go back and expand this using FOIL or the array, and you should get back up to 81y squared minus 4. Number 3, bigger numbers, still perfect squares. Root of 36 is 6. Root of s squared is s. Root of, and that looks like 65, but it's supposed to be an s. There we go. Root of 121, t squared. Root of 121 is 11, and root of t squared is t. So a grosser looking one, 6s plus 11t, 6s minus 11t. Same. All right, now let's look at number 4. It's a binomial, but it's still a square. And the root of it is simply x plus 1. Because if you do x plus 1 times x plus 1, you will get x plus 1 squared. I haven't expanded it, I'm just getting the root. And the root of 4 is 2. So when you build this one, it's going to be, I'm going to move it down here. You need some different types of brackets. X plus 1 minus 4, x plus 1, oh sorry, minus 2, my bad, x plus 1 plus 2. And this one you can actually drop the brackets and change this completely, which is kind of a mindfuck. But it could look like x minus 1, because positive 1 minus 2, onto x plus 3. And that should give you the same answer when you go back, but it won't look like the same one because it'll be the same as if you took this and expanded it. So watch out. So if you did that and then minus 4, you're going to get the same answer as if you expanded this one. Okay? Just kind of a neat extra work one. All right, so remember on that first slide, I said you need 2 perfect squares. So when I look at number 1, I'm like, well, 5 isn't a perfect square, nor is 125. However, this has a common factor in both terms of 5. So take that out first and see what you're left with. And suddenly the stuff in the brackets are 2 squares. Root of a squared is a, root of 25 is 5, Root of a squared is a, root of 25. And I'm just showing you, I honestly just write them down and then I put a plus in between one and a minus in between the second binomial. And you're done. Common factoring for number 2 first. You can take out a 2 and you're left with b squared minus 36. And b squared and 36 are both perfect squares, are both squares. And we're going to have b minus 6, b plus 6. Number 3, they both have an x. 27 is divisible by 3, so let's pull out 3x and see what's left. 9 minus x 4. Okay, 9 is a square, x4 is a square as well. The root of x4 is x squared, because if you did x squared times x squared, you would get x4. Okay, so it's all good. All those even variables, even exponent variables will be perfect squares. Okay, the numbers first, that doesn't matter. So I'm going to do 3 minus x squared, 3 plus x squared. And that's as far as I can go with this one. Looking at number 4, so you can either take out negative 4. They happen to be perfect squares, but you can also factor this one. Or if you don't like the negative in front, you can change the order. It doesn't really matter. You could look at it like this. And then be like, oh, I can take out 4 and have 25y squared minus x squared. And there you go. 2 squares. The root of 25y squared is 5y. The root of x squared is x. And you just write it down twice with a different sign. And that's a pattern. Looking at number 5, root of x4 is x squared. 1. The root is always 1. Now be careful, am I finished with this one? My first binomial is done. I can't factor that any further, but my second binomial here is still a difference of squares. X squared and 1 are still squares, so you can take that further. So you write down your first one again because you didn't do anything else with it, and then factor your second one. Root of x squared is x. Root of 1 is 1. X minus 1. So there we go for difference of squares. Now let's move into factoring trinomials. So we're going to look at 2 types, simple and more complex trinomials. So my notes on trinomials. When I say trinomial, I mean a second degree equation. So my biggest power would be a square on a variable. They're also the standard form of quadratic equations, which is where, like it or not, if you got to this point, you have seen it before. You just probably blacked it out, as many people do. So when we write the standard form, and this is important because we'll use this again, we always make them with this ax squared plus bx plus c, okay? And a and b, as well as c, can be any number. They can be minus 5, they can be plus 21, it doesn't matter. But a, b, and c represent numbers that go with variables. So if you look at our examples, we have x squared plus 6x minus 23. So in that case, a always goes with x squared, and I can't see a number, so a is 1, which is important. And b, is 6, and c equals negative 23. If your trinomial is not in descending order, that doesn't change anything. A still goes with the x squared. So in this case, a is negative 7. B goes with x always. B is 3. And c is negative 2. So we're going to start with factoring simple trinomials, and that just means a is 1. So your leading term will be x squared without anything in front of it. Okay, so looking at our examples, is number 1 simple or complex? Simple, right? Because A is an invisible 1 in front. So simple for number 1. What about down here? Simple or complex? There's a 1, but it's not the A value. A equals 3. So this is a more complex one. Looking at number 3, simple or complex. Now be careful, because remember, common factoring. This is where you really want to be using your common factoring. It looks like a complex trinomial, but I can divide 2 out of all the terms. And it has some y squareds as well. That's fine. We're looking at these x terms. And in this one, once we factor out that 2, we see that we have an a that is equal to 1. So this is actually simple. Be careful. And for our last one, the term in front is not the a term, it's a b term. A is actually -4. So this is complex. There are a lot of strategies for factoring trinomials. I'm a big fan of the product and the sum strategy. So this is how I set it up. There's a lot of information in these next few slides, but I'm going to take you through. So if you are given a trinomial and you have ax squared plus bx plus c, and we're going to say a is 1, we're going to look for factors of ac. And when I say ac or the ac line, that means a times c. Now, in simple trinomials, a is always equal to 1. So the AC line really is just whatever c value you see there. And the b line just takes the b from there. So if I look at one with real numbers, your AC line is always a product. It's always a multiplication. And you're going to take a times c, so 1 times 10 goes there. And for your b line, it's always an addition line, and it always looks for that b value. So what I'm really telling you is that I need to find 2 numbers that multiply to 10 and add to 7. So you're always going to be taking that AC line, and you're going to be looking for factors of 10. How can you make 10? You can make 10 by doing 10 times 1 or 5 times 2. So if this is going to be factorable, some of those have to work. 10 times 1 makes 10, but 10 plus 1 adds to 11. No good. 5 times 2 multiplies to 10, and 5 plus 2 makes 7. So that is good. And when we put that into factored form, we're just going to write x plus 5, because that's a 1 factor we found, and x plus 2. There's our second factor. And if we go back and expand these using FOILs, guess what we're going to end up? Right back at x squared plus 7x plus 10. So now I want to break down what you can expect to be doing with different values of b and c. So you can have 4 combinations. You can have positive b value, positive c. So the first thing I always look at is the c value. And let's just use our same example there, x squared plus 7x plus 10. If your c value is positive, it means that you had to multiply 2 positive numbers or 2 negative numbers. So when I look to the b value, so I check for c, so I know I'm going to have numbers or factors with the same sign. And if I look to the b value, if it's also positive, I know I've created this situation. Two factors that multiply to 10, 5 times 2, and add to 7, 5 plus 2. Now, I can still have a positive c value, but end up with a negative b value. All that means is I'm still going to use 5 times 2 equals 10, but in order to make 5 and 2 equal -7, they must both be negative. -5 times -2 is still positive 10. -5 plus -2 is -7. So in this case, I look at my AC and my B line, and I discover that to make this combination, I need x minus 5, x minus 2. If C is negative, we know that our two factors will have different signs. So let's look at x squared plus 3x minus 10. And we're going to do the AC line thing again. We need to make negative 10. A times C has to equal negative 10. And A plus, sorry, sometimes my multiplication signs look like plus signs, has to equal positive 3. So we know to make negative 10, we're going to have one positive, one negative. And the key with this kind of thing is look to your B. If B is 3, you're looking for factors of 10 still, and I'm dropping the idea of negative 10, that are 3 apart. Okay, so my choices still remain 10 and 1 or 5 and 2. 10 and 1 are 9 apart, so it's not going to work. But 5 and 2 are 3 apart, and that's my B value, so that will work. So I'm going to write down the 5 and the 2. And I'm going to look to my B value. Now, my B value is positive. So that means the bigger number, the bigger absolute value of a number must be positive. So I'm going to make the 2 negative. And I'm just going to check it with my little product sum lines. Is 5 times negative 2 negative 10? Yes. Is 5 plus negative 2 positive 3? Yes. So when I do this, my factored form, x plus 5, x minus 2. And let's take it down here for the last combination, negative B and negative C. I still need to make negative 10. And I need to make negative 3. So same idea. If C is negative, that means you're looking for factors of 10 that are B apart or 3 apart. Okay, it's going to be 5 and 2. But this time my B value is negative, so my bigger number has to be negative. My bigger absolute value has to be negative. So I do this, and the factored form of this number will be x minus 5, x plus 2. So 4 kind of combinations. And here's it all summed up in a chart. I'm going to make this a little bigger. So if C is positive and B is positive, you're going to have 2 positive factors. C is positive, B is negative, you're going to have 2 negative factors. And depending on whether B is negative or positive when C is negative, it tells you which number will be negative, which number will be positive. But you can always test it with the math. So let's do some and do it the long way. So that AC line and that B line. AC is always your product line. I need things that are going to multiply to 1 times 6, which is equal to 6. And I need things that are going to add to 5. So always looking at factors of 6. My choices are 6 and 1 or 3 and 2. 6 and 1 add to 7, no good. 3 and 2 add to 5. There you go. B was positive, so I know that they're all going to be positive, and the answer for this one will be x plus 3, x plus 2. So notice I'm taking whatever I put into these blanks, and that goes into my factored form. All right, let's look at number 2. I need to multiply to 8, positive 8, yet add to negative 6. So I see that C is positive and B is negative, so I'm looking for 2 negative factors. Factors of 8, I'm just going to think about what those are. I can have 8 and 1, or I can have 4 and 2. 8 and 1 are going to add to 9, no good. 4 and 2 add to 6. So 4 times 2 is 8. 4 plus 2 is 6, but I need to make negative 6 and positive 8. Everything's negative. And my factored form of x squared minus 6x plus 8 turns into x minus 4, x minus 2. Check your answer. use FOIL, try and get back to your original trinomial. If you can't get back or the signs are different, you did something wrong. All right, number 3. I need to multiply to negative 9. And because c is negative, the two things that are going to multiply to negative 9 must be 8 apart. How do I make 9? 3 times 3. Oh, that's 0 apart. That's no good. And 9 times 1, which happens to be 8 apart. So those are the correct factors. So I'm going to do 9 and 1. 9 and 1. 8 is positive, so 1 must be the negative 1. 9 plus negative 1 equals positive 8. And my final answer, last example, I need to multiply to negative 20, so I'm looking for one positive and one negative number. And I need to combine or add negative 1, which means the two factors must be 1 apart. How to make 20? More choices. 20 times 1, 10 times 2, 5 times 4, and I think that's it. So these are 19 apart, so that's no good. These are 8 apart, so that's no good. 5 and 4 happen to be 1 digit apart, so they're going to work for me. Who's going to be positive? Who's going to be negative? Look to this. I need to make a negative answer, so the bigger absolute value will be negative. Just making sure both those AC and B lines are true. Yep, I did it right. All right, so just kind of piling on a bit. Now remember what I said. You can factor number 1 with the negative in front. Pull it out. I would pull it out. It's way easier because then you have just kind of your positive A and you don't have to think about anything. And factor the stuff inside the brackets. So I need to multiply to negative 15, the AC line, and I need to be 2 apart because C was negative. 15, your choices are 15 and 1 or 5 and 3. 5 and 3 happen to be 2 apart. There you go. One of them has to be negative to make this work, and it's got to be the 3. So when you write your answer for this one, anything you took out, here it was just negative 1, remember to write it in front of the two binomials. That's my classic mistake. I always forget about the stuff. Sorry. Put that back. X plus 5, x minus 3. And if you were to expand the binomials and then distribute the negative 1, you'd end up right back here. Okay, so let's look at number 2. I've only told you how to factor simple trinomials, so I bet you can divide out the 3, that's the A value. And you totally can. All of these terms are divisible by 3, so pull it out. 27 divided by 3 is 9, and 60 divided by 3 is 20. So looking around before I start, I'm going to have something times something equal positive 20. And those same two factors must add to negative 9. I know they're both going to be negative because they made a positive number. So 20 factors, once again, 20 and 1, add to 21. 10 and 2, add to 12. 4 and 5, add to 9. Those are my factors. And because 9 was negative, I need them both to be negative. So my final answer for this one, don't forget to write that 3 in front. Number 3, we've got a 2 in front and a negative. Pull them both out. Negative 4 divided by negative 2. Negative 2 divided by negative 2. All right, so now we're going to factor. I need to multiply to 1 and add to 2. Well, there's not many choices here. The only way to make 1 is by multiplying 1 times 1. And it happens to be that when you add them, they make 2. So my final answer here leave that negative 2 in front, and then x plus 1 squared. Or you could write it as negative 2x plus 1 times x plus 1. Same. Last one, we're ending with an easy one. We need to multiply to 11 and add to 12. Well, 11 is prime, so the only way to make it is 11 times 1. And that's one we often forget about. Don't forget about that number times 1 as being possible factors. 11 times 1 is 11, but 11 plus 1 is 12. And our factored form, x plus 11, x plus 1. There are lots of ways to do factoring. So if this isn't gelling for you, or if you have a system that worked before, go ahead and use them. I'll absolutely put up some resources in the shell that you can look at.